What did the carpenter say as he cut down the oak? I saw me tree. So the joke is, isometry is a transformation that does not change the shape or size of a figure, and we will be studying reflections, which are isometry. So I had to kind of stretch on that one. So what are reflections? You've done them a long time. You did them in middle school. You reflected across a paper and you folded it. But basically, if I'm looking at this graphic here, and I can put a link on the website so you can play with it, a reflection basically moves the points across a line so that the distances are the same. You can see as the closer I get to a line from the original point, there's my original point, I get really close, then the image gets close. The further I move away, the further the image moves away. So the pre-image and the image are related in the sense that they're both the same distance, as you can see there, from the line of reflection. So let's go ahead and reflect a polygon, C, D, E, F, G, H, and we're going to go through the exercise of filling out the image and finding the midpoints. So point C, you can see, is at negative 5, 5, and point C prime is at 5, 5. The midpoint halfway between them is at 0, 5. D is at negative 10, 15, and D prime is at 10, 15, and there's the midpoint. So I went ahead and put in the rest of these points to show, you can see there's F, which is right here, negative 5, 0, and 5, 0, and I put in the midpoints. You should notice something in common with all the midpoints. In fact, the midpoints all fall on the line of reflection, because they should be. The points should each be equidistant from the line of reflection, so the line of reflection should be halfway between any 2 points on the image and pre-image. So what is, in this case, this is a very special case, what is the equation for the line of reflection? Well, you notice all of these points, x is 0. Well, I could just say x equals 0, which also happens to be the y-axis. So write this down in your notes. I did not get this down. The rule for reflection across the y-axis, if you look at how it goes from the pre-image to the image, it's basically the only thing that changes is a sign on the x-coordinate. All the values stayed the same, but x became negative x. Y stayed y. So the other thing I wanted to look at is I connected these points with their segments, and I want to compare the slopes of these segments to the line of reflection. Well, the slopes of these segments are 0 because they're completely horizontal. They go up 0 and over who knows how many. Here up from E to E prime, up 0 over 2, which is still 0. The line of reflection is vertical, so the slope is undefined. That means the segments are perpendicular, and we can say the line of reflection is the perpendicular bisector of the segments connecting the image and the pre-image. Let's go ahead and look at a reflection vertically, where we're reflecting across the x-axis now. So you can see I've got my image points here, and I filled in my pre-image points are here, and my image points I filled in, and then the midpoint. So we went from C, negative 5, 10, to C prime, negative 5, negative 10, and the point halfway is at negative 5, 0. Filling in the rest of these, you should see a pattern as I fill them in for the midpoint. First of all, there are two patterns to see. One is that the only thing that's changing is the y-coordinate, and I'll have that rule on the next slide. So the y-coordinate is changing sign. And the other thing you'll notice about the midpoints is they all lie on the line where y equals 0. The x's change, but the y's always stay the same. So the question here are the segments the perpendicular bisectors of the line of reflection? Well, this is a segment. Is it cutting the line of reflection in half? Well, no, because the line cannot be bisected since it goes on forever. And this is the rule I wanted you to get in your notes. Go ahead and write that in. For reflection across the x-axis, the only thing that will change is the y-coordinate. Not something, you should be able to figure this out on your own without writing down the rule, but it is a handy shortcut if you can remember it. So for further reflection on this part of the video, where can you find the midpoint between the pre-image and the image? Hint, reflection line. If you can find the slope of the segment connecting the pre-image and the image, how does that compare to the slope of the line of reflection?